Hello YouTube and welcome back to Kind Heart Homestead. My name is Ben and I'm up here on our off-grid property in the mountains of Virginia. Behind is our 80-foot by 80-foot garden area. We just finished the fence on this. That's a two-part series you can go watch on our channel. Please subscribe if you haven't already done so. That way you can stay up to date with our projects. Well, since we're planning to spend a lot of time in our garden this year, doing beekeeping, raising chicks, all sorts of stuff like that, we need a structure to provide some shade and to keep our tools dry from the rain. So we've decided to build a tool rack, which is going to consist of 2 posts with a small gable roof overhead. It's going to resemble one of those trailhead kiosks that you would find at like a state park or a national park. You get out of your car in the parking lot, there's a small roof with a sign on it that's going to say like the name of the park, the map, and there might be some pamphlets in there. Basically, it's a structure just big enough to keep you and your backpack out of the rain and to keep the materials that they're advertising dry. So we're basically going to be using it for the same thing, minus the map, but we will have plumbing and electrical on it. That way we can mount our irrigation controller, maybe an electric fence energizer, things like that. That stuff's not going to be in this video. You might see some basic electrical getting the wire up there. But we're pretty excited about this project. By the end of this video, we're going to be done with it. So don't expect another 2-part series like I've been doing. I'm going to try to condense and cram as much information into this one video as possible. So if you want to see how I build this, stick around and I'll be right back. Alright, the first order of business is the 6x6 pressure treated posts. My goal is to embed these 3 feet into concrete, but just for some added security, I'm drilling some 1/2-inch holes somewhere around the midpoint of what's going to be underground. That way I can hammer 1/2-inch rebar into it. I don't really want the rebar to be loose and go all the way through the board. That means it would have like really good hold on the concrete, but not so much on the wood. So what I'm doing here is drilling a hole slightly smaller than the rebar, so when I hammer it in, it's really stuck and there's no way to get it back out. And then I'm going to use an angle grinder with a metal cutoff wheel to cut off the excess and just leave a short little stub just big enough so this whole assembly can fit into the hole. I'm going to repeat this process for every side of the pressure-treated post. And I have to make sure not to leave these too long because I do need to bear hug this post and kind of guide it into the proper place in the hole, and I don't want the rebar going into the dirt. Most structures that I build are 3-dimensional, and what I mean by that is that there's multiple walls, more than 2 points of contact with the earth, so the load is actually spanned across several points or maybe some sort of bottom plate or footing. In this case, I'm considering this a 2-dimensional project because the posts that go up, there's only 2 of them, and I'm worried about the wind knocking it over. We have really heavy wind up here on the mountain, so I'm relying on this rebar to hold the posts down into the hole. I'm not really using them to reinforce the concrete as much as just to hold the posts down. So now that you know the logic behind my process, here is a close-up of these little rebar pins sticking out of the pressure-treated post. This is a close-up of the hole that I dug for the first post. I would estimate that it's about twice as big as the holes that I dug for the fence posts. As you might expect, the next step in the process is to use brute force to move the 6x6 post over to the hole. Thankfully, the weather has been very dry lately, and it's a lot lighter weight than it was when I first transported it to our property. And as is typical for most concrete work, it's important to use some sort of temporary bracing so your woodwork or whatever you're embedding into the concrete doesn't shift while you're pouring the wet concrete in place. If you don't do this, you really have to race the clock and level and plumb your posts before your concrete cures. In this instance, I'm bracing my structural posts with some 2x2s that I had lying around. What you'll see in a couple seconds is that I'm actually screwing one end of each of these 2x2s to my pressure-treated post, and the other end I'm screwing it to the fence as an anchor point. That way I don't have to install any stakes in the ground, and I reduce the risk of me tripping over things. And now it's time for the messy part. I have a few bags of concrete, 80 pounds each, in the back of the pickup truck. I parked the truck as close as I can to the gate so I don't have to carry the bags as far and risk injuring my back. I can flip them straight off the tailgate into the gorilla cart, which I only have to pull another 8 feet or so. Again, trying to reduce risk of injuring my back. I've been through physical therapy recently. I've been doing exercises, but I still need to have really good posture, and it's very difficult to have good posture when you're carrying concrete. So, with everything as close as it can be, I'm then pouring one bag at a time into the concrete mixer, shooting the water with the hose until it gets to a consistency where it can be poured and settled down into that hole. And then I just keep repeating that process till I get through 3 bags. I wasn't planning on 3 bags necessarily, but that got me just below grade. And then I just hose off the wood and clean up the job site. Here's a close-up of how high the concrete got from those 3 bags.
I just removed the temporary bracing. This is a 6x6 pressure treated post, really tall as you can see, and I buried it at least 3 feet into the ground. I bought 3 bags of concrete, 80 pounds each. I thought that would be too much, but it turns out we're still down like 5 inches or so below grade. Anyway, I have to install another one of these, 6 feet that way. This level is exactly 6 feet long, so I'm going to use this as a guideline to make sure my next hole is square, and it's 6 feet from the outsides. That way I can cut a 12-foot board in half, put it across just like this twice, one here, one up here, and then I could use 8-foot lumber for a roof structure. That way it'll overhang on both sides, should overhang all the way to the fence line. So I'm gonna get started on that now.
So now it's time to repeat the process. This time you'll get to see me actually dig the hole. You saw that I put a small rock exactly where the center of the hole needed to be, and that's just a placeholder that I can dig around. It's not going to be in my way too much. I can always just kick it out once I'm done. Basically what I do next is similar to what I do with the fence posts. That's use the contour of the shovel to establish a circle, remove the full piece of turf in one piece, and then I dig as deep as I can with the shovel before it requires me to widen the hole anymore. And at that point, I know I need to switch to the post hole digger. Instead of getting out the gas-powered auger, I decided to just use this manual post hole digger, mainly because every time the auger hits a rock, it really hurts. It kind of rips the machine out of my arms, and I have to do my best to hold on to it, and that can cause injury. Another reason is because my largest auger is only 8 inches in diameter, and that's roughly the same diameter as these posts, so there wouldn't actually be any room for the concrete. So by using this manual post hole digger, I get to shave the sides down to make sure it's perfectly cylindrical, there's no taper at all, and then once it's wide enough to accommodate the post, plus those rebar pins that I attach, then I know that the width is good enough. Another trick you saw me do is lay that little scrap of zip sheathing over the hole. Doesn't have to be zip sheathing. You could use a level scrap 2x4, even a handle for a shovel or a rake. That way you have a grade guideline that you can measure with the tape measure up to. In this case, I hit bedrock, or at least some very large stone that I couldn't dig around, and I was 3 inches shy of my 3-foot goal. But I figured 3 inches is just fine. It's going to be close enough to the depth of the other one, and I can always just cut the top off to make sure that the two are level with each other. Now that the second post is in the hole, I need to do my bracing again, and I'm also using my 6-foot level to make sure that they're perfectly spaced, 6 feet one end to the other. I'm repeating the exact same process for the second pressure treated post. I don't want to go into too much detail because you basically get the gist. The only difference now is that I have a little brace that I can hang the hose on. That way I don't have to bend down a couple times to get to the hose. This post is also probably about 5 or 6 feet farther from the gate, so it is a little bit farther to move the concrete. But using the gorilla cart for the dry concrete and the wheelbarrow for the wet concrete makes things perfectly reasonable, moving the load back and forth. I never put more than one 80-pound bag in that concrete mixer at a time because I don't want it to get too top heavy and risk falling over. You can't really see what I'm doing in the gorilla cart because it's concealed behind the mixer, but I'm using a very sharp blade to essentially cut the concrete bag in half so I can carry one half at a time, which is only 40 pounds instead of 80, to the concrete mixer. Because this post hole was a bit more shallow than the other one, I struggled to fit all of the concrete in there. That's why I'm using this scrap piece of rebar to remove the air bubbles and settle the concrete. One thing that I've learned from experience is that you should always clean off your concrete tools before the concrete dries. Otherwise, you're going to have an abrasive mess all over your tools. And all you really need is some water pressure and some good aim with the hose. Now it's time for some very basic electrical. I'm not an electrician and I don't want to give you guys advice because I don't want to be responsible for you injuring yourself or damaging something on your property. As the homeowner, I'm allowed to do it, but I can't do it on someone else's property. That could be the same in your state. You might want to talk to your local inspectors if you really want to know that for sure. But I've been doing my own electrical work for years. I've installed a couple breaker panels. I wired my entire solar system myself, including the batteries, the inverter, the charge controller, and the breaker panel in the utility room. Again, I didn't want to get in depth with those projects because I'm not 100% sure I did it right. I actually have yet to get that stuff inspected, but I know that it's been working very well for the past 6 months. What I'm doing now is attaching this 90-degree conduit adapter to the top of my conduit pipe that's coming out of the concrete. Then I attach a scrap piece of conduit that I cut off of the same piece to go through the timber and out the other side. Although I do have to continuously take the pipe back out and trim it to length because I want to make sure the boxes on both sides of the post are flush. That way nothing's flapping in the wind. Eventually I can put clamps on the other side of the post to hold the conduit securely to it. That might not be 100% necessary because the conduit actually goes through the concrete and out the other side, just in case I need to pull the wire back through. All I'll have to do to pull the wire through is dig a small trench next to the concrete, just down to get to the wire, and then I can pull it back out of the conduit. Now I'm installing a weatherproof housing on top of that box. That way I can keep extension cords and other AC devices plugged in and still shielded from the weather. Eventually I will add a GFCI outlet in here and a second outlet that is protected by that same GFCI. Here's a close-up of the weatherproof housing and the conduit 90-degree adapter. I hope you guys didn't get too bored with that basic stuff, but now is the fun part. I designed this in SketchUp several months ago and decided not to study it or print anything out and just kind of wing it. I trust my instincts. Having designed so many things in SketchUp, I just kind of go through the, I guess you could call it muscle memory of the brain, where I just trust my logic and my thought process to be consistent enough to produce a similar result to what I've come up with a previous time. In this case, I'm cutting a 12-foot 2x6 roughly in half, so I'll have 2 horizontal boards that shovels and stuff can be mounted on. But I honestly had no idea where I wanted to hang the shovels from. Ideally, they would be high enough for Cedar not to be able to reach, but he's going to just get taller, and realistically, we just need this to function in an efficient manner. So, you see I have a short shovel and a long shovel. I based the first board on the height of the shortest shovel. That way we can make sure everything we have can lean on it without falling through, falling out the other side, getting rained on. And then I'm using that short shovel again to measure the distance between that bottom board and the upper horizontal board. That way, if we put hooks and stuff on the second board, the shovels can all hang down and touch the bottom one. That way, they're not flapping in the wind and falling off. You might think flapping in the wind is my new favorite phrase, but if you've been up here, you would know the top of our mountain has tons of wind all the time, and we've had several things get destroyed because of it. We had a soft top carport from Harbor Freight. We also had a pretty nice pop up canopy from Costco. Both of them got completely destroyed by the wind. The Costco one we were able to return, the Harbor Freight one, it just wasn't worth trying to get any money back. It just got destroyed, and I think we can use some of the parts for other things. All right, let's get back to the topic at hand. I'm installing the upper horizontal board, and my arms aren't long enough to hold this board in the exact level position that I want while also securing it. That would be a two-person job. So instead, I'm essentially inventing a spare hand by using a screw. You could use a nail or a board, any number of things. You just need to be able to temporarily clamp one end of the board to its rough final destination. Doesn't have to be exact. You can always move it later since you're not actually attaching it, you're just balancing it. But you need to hold one side up so the other side can be appropriately attached with one screw. Just use one, that way you can use it as a pivot point to get the other end to the exact spot that you need it. You can remove that block, temporary nail, temporary screw, whatever's holding it up, and then have one screw in each side, and then go back and add your permanent hardware and fasteners. I might come back later and use some big washer head structural screws. Those will suck the twist right out of these boards and make them flush with the posts. But for now, a couple of 3-inch decking screws is all I need to move on. Next is an assembly you might be familiar with if you have any experience with post frame or pole barn framing. I'm constructing a double header, but instead of the two plies touching each other, they're spaced onto each side of these posts. You could obviously add a lot of strength by notching out the posts and recessing these into a half lap joint, but since this isn't supporting any sort of living space where people are going to be walking, I don't really feel the need to waste all that time and effort notching the posts. All this has to support is these 5 little 2x4 trusses and some metal roofing panels. The first truss always takes me the longest, so I did that off camera. But once I assembled one, I'm using it as a jig to construct all the other ones. Every time I cut a board, I can screw it onto the sample truss so it can stay in position while I fasten it to the other components. That way they all have the exact same dimensions. These obviously are not engineered trusses, and I also don't have the type of plates that typically fasten truss components together. I'm just using standard decking screws of various lengths depending on how much material I have. Again, I decided not to waste any time consulting my official drawing on SketchUp. Instead, I just chose an arbitrary slope of, I think, 15 degrees, which is a few degrees off from the solar shed in the background. I don't really know why I chose that number. It just seemed good to me at the time. Regardless, I am using a 6-foot bottom cord on the truss, and then I'm cutting at a very acute angle the 2 other ones that form the ridge. It's a pretty elegant looking triangle, and it's going to have a 8-foot fascia board on each side, which is going to lock all of the trusses together and make it act all as one unit. It's basically just going to balance up there on the double header until I decide exactly how I'm going to secure it to the double headers. One thing you might notice is that I'm using the Gorilla Cart as a workbench. That only works because I'm not passing any screws straight down through, risking damaging the plastic. I have to make sure anywhere where the saw blade is passing, I'm overhanging either on the outside or the inside of the cart to make sure that I'm not going to damage the cart in any way. I'm pretty used to this, so it's not that risky, but I do recommend if you don't have much experience, get yourself some sawhorses. Here's one of my more genius plans, if I do say so myself. I need to figure out a way to lock the tops of all the trusses together so they can't lean over, and so I have a surface to mount the upper edges of the metal panels to. To do that, I want to insert purlins into the tops of the trusses. What I actually mean by that is to recess them into a notched cavity. I don't think I'm going to be removing too much material to compromise the trusses, but it does need to be 1.5 inches in depth to accommodate a full flat 2x4, just because I don't have any 3/4 inch material on hand. I do have plenty of 8-foot 2x4s though, so that's what I'm planning to use, and that should be plenty suitable to both brace the trusses and to support the top of the metal. The genius part is just another aspect of efficiency that I've probably seen on YouTube somewhere before. I'm clamping all of these trusses together so I can make my notches in bulk. I make a bunch of passes with a circular saw adjusted to the 1.5 inch depth, and then I'm using a hammer and chisel to remove the little blocks and to expose the 1.5 inch depth notch that's also 3.5 inches wide to accommodate a full 2x4. If you were doing actual finished carpentry joinery or something in like the furniture making industry, you would probably want to trace your board with a sharp blade to make sure the tolerances are tight enough to where you don't see the seam. But this is just rough framing. The boards are inconsistent, they can be bowed, and they're also rounded over on the corner, so you can't really trace the board to get an exact guideline for where you need to chisel out the wood. I basically just used a tape measure or a speed square to measure roughly 1.5 by 3.5 inches. And then I'm just using some scraps of wood as a placeholder to just see if a dimensional piece of lumber would even fit in the notches. The trusses are done, and now it's time to move on to the subfascia boards. This is the 2x4 framing that's going to tie all of the trusses together on the outer edges. These came just over 8 feet from the mill, so I'm cutting them down to 8 feet, and then I'm drawing my layout marks to know exactly where the trusses are going to sit. That's something I like to do when I'm building by myself because it's going to be very difficult to use a tape measure while I'm up on a ladder. So this way I'll be able to see a line drawn on both sides of where the truss is going to sit. So when I look on the underside of the assembly while I'm up on the ladder, I'll be able to know exactly where it goes, and I can finish driving these screws that I'm starting here. I believe these are 3-inch decking screws, and they should be perfectly strong for this application. I'm transferring the lines from the 8-foot subfascia board onto the double headers. That way, when I'm setting the trusses in place before I get the subfascia up, I kind of have a good guideline of where they're going to sit. This is not really necessary, but because nothing's really going to be attached up there, it's just going to be floating, I can easily bump these trusses out of the way. So having some lines drawn is going to make it a bit easier just to know where they go. You can see I have the ladder leaning on the assembly right now. That's going to be too close to comfortably operate the impact driver to get the subfascia installed onto the edges of the trusses. Since there's not too much wind, I'm not worried about them falling over and hitting me in the head. But just to tack it in place, I'm going to slide an 8-foot board through the trusses. And I'm tacking in one screw on each post just to make sure they can't fall over. Another trick I'm doing, similar to my screw technique from earlier in the video, is I'm tacking a block of wood to the underside of one of the end trusses. That way I can balance the wood on it as I pull it up into place on the other side and get it secured. Now that the two ends are secured, I can go secure the 3 interior trusses using those decking screws I had already started. And now instead of leaning the ladder on the assembly, I have it freestanding because as you can see, the trusses aren't actually attached in any way to the posts. If I put too much pressure or weight on one side, I could slide it all the way off of the other one if it wasn't for that board I tacked in place on the inside of the trusses, which I'm going to remove shortly once I start getting preparations made for the metal roofing panels. Building such an informal structure like this, there's several ways you could design it. You could use a ridge board or a ridge beam, cut trusses, cut rafters. This is just the way I decided to do it, and then I went back and secured the double headers with these large timberlock screws with the washer head. Well, it's supposed to rain tonight, so I want to wrap up the first phase of this project, which is getting the roofing up onto the framing. I do have a bit more framing to do. If you can see behind me, I made these horizontal, I guess you would call them purlins. That's essentially a nailer for the metal. I need to do one more near the edge of the overhangs, so I have somewhere to secure these scrap pieces of metal to. These were all scraps from our solar shed project, things that were cut out for doors and windows and things like that. I actually have some significant material here, so I'm going to use all the scrap that I can. They're not going to be full 3-foot wide pieces with that 2-inch overlap. Instead, I'm probably going to have to do a bunch of like 9-inch pieces overlapping each other by just one rib. We'll see how far I can get with this material. I'm not too concerned about what it's going to look like on top, but we've had this metal sitting around for so long that it's a great way to use it up, and it's going to match the building over there. So let's get started. So instead of installing another purlin at the bottom of the slope to attach the metal, I'm installing blocking in between the trusses. The main reason I'm doing this is because there's actually no room to comfortably notch out any more of the truss without hitting the screws where the top cords connect to the bottom cord of the truss. So I'm using a common carpentry technique called blocking. It's used all the time in residential construction, behind the drywall, anywhere where maybe cabinetry or another heavy load would be mounted. Blocking is used so you don't have to use drywall anchors to support the load. You have something behind there. And I'm basically using the same concept here. I'm putting blocking behind the metal where the screws need to go, so there is somewhere for the screws to hit. So I'm just installing whatever panels that I have. I started with the biggest ones, moved my way across. I believe each of these are maybe 38 inches long, something like that, just over 3 feet. And I was able to get 2 pieces out of a couple of the scraps. So I'm really happy about that. Now I'm going to do a bit of a creative camera angle to show from underneath what it looks like as I install the metal. I'm not actually securing these to the trusses. I'm securing them to that top purlin and then the bottom blocking. Usually manufacturers don't recommend going beyond 2 feet for your screw pattern. I'm closer to 3 feet, but because this isn't a habitable dwelling and there's already some holes in this, I'm not worried about leaks at all, and this should be plenty strong for this structure. So moving on, I need to get a ridge cap installed. Unfortunately, I don't have enough matching ridge cap to span the length of this 8-foot structure. So what I'm doing instead is cutting the largest piece in half. This is one of the halves that I'm installing. I'll align it with the edge of the gable on this side. I'll install the other half on the other side, and there will be a gap in the center, which I'll span with a different color and a different size ridge cap. So it'll look symmetrical if it's ever viewed, even though there will be 2 different colors of ridge cap. The outer ones will be brown, and the center one will be white, and that center one matches the ridge cap on the solar shed in the background. One thing I didn't really touch on much is how I'm cutting this metal. I have a few different tools for cutting metal, but the one I chose to use for this project was the Vever Nibbler. Nibblers are really cool because it removes material as you go, and you can cut in curves, and you can cut right over the ribs on the metal. Click on my affiliate link below if you want to view Vever's tools, and that'll help support our YouTube channel here at Kind Heart Homestead. To finish this phase of the project, I'm installing screws rated for a hurricane uplift. This replaces the metal plates you may have seen, but I have a few left over from the solar shed build, so I'm just going to use them up. For now, I'm going to stock the tool rack with a bunch of shovels and stuff just by setting them on the ground and leaning them against this bottom horizontal piece of wood until I can get some hooks or some mount plates, something that would allow us to hang them suspended off the ground from the second horizontal. That was a lot of work, but as you can see here, the garden rack is done. I'm just going to call it the garden rack. Could be a tool shed, but you know, we have the garden shed over here. We have the solar shed over there. We have a lot of sheds. And this is more of like a trailhead kiosk than a shed. So let's just call it a rack. I ended up straying away from the original design I drew in SketchUp because it's just kind of hard to visualize in SketchUp, which is kind of ironic because it's all visual. But like when I draw a 6x6 post, I draw the section that goes underground as well, and then just kind of establish where the grade is. You can't really tell the scale of anything in there, except if you like download a human clip art image and put it next to your thing. But even then, that's third person and not first person. By the time I had these 6x6 posts up and I realized how tall they were, I decided to just put my 2x6s across as double headers, mounted to the sides instead of lapped inside like I do with Cedar's Playhouse, just because there's no actual human weight being sit on this. So I used up the rest of my roofing material, which was the siding of the solar shed, and this is all the scrap I have left. Just a few manageable chunks. I could carry these all at the same time, unlike the stack that's been sitting here in the garden. Anyway, we're really happy to have this rack done. Now we can keep our tools near the garden where they're needed, and they can be dry. And I'm north of it right now, and that means that most of the day there's going to be shade cast by this structure. So that's going to make things easier as well. Marie is actually already enjoying the shade. So if you want to see more builds like this, more garden projects, more construction, go ahead and subscribe to our channel, and I'll see you back here next time on Kind Heart Homestead. Thanks for watching.